Okay, so let's say that we've got a meteor that is coming towards the Earth and it is entering the atmosphere, and I've chosen a rather slow speed for the meteor, which would be maybe terminal speed in the atmosphere, which it wouldn't reach 50 meters per second or so. And let's say Superman is trying to reverse the direction of the meteor. And so the meteor is 5,000 kilograms. Superman, who's 100 kilograms, is flying at 2,600 meters per second towards the meteor going at 50 meters per second. They suffer an elastic collision, so that the meteor is reversed in direction and is then going 50 meters per second away. How fast must Superman recoil from this collision? Well, you could absolutely do momentum conservation. And actually momentum conservation would do it, but we can also just use the relative velocity formula and say, it's an elastic collision, so the relative velocity must be the same before and after the collision. Before the collision, if Superman is going 2,600 meters toward the meteor and the meteor is going 50 meters per second toward Superman, then their relative velocity is 2,650 meters per second, right? They're going faster relative to each other than they are each going relative to the Earth, right? It says 2,600 meters per second relative to the Earth, 50 meters per second relative to the Earth. So they're going 2,650 meters per second relative to each other. The other way to look at it is that if you take this equation here at the top, this is 2,600, we could call this 2,600 meters in the x direction, and this is 50 meters per second in the minus x direction. Plug that in, and you'll find it's 2,650 meters per second relative velocity. So that's before the collision. Therefore, after the collision, they must also have a relative velocity of 2,650 meters per second. And since the meteor is now going 50 meters per second away, then the man must be going 2,550 meters per second in the opposite direction. So if after the collision, Superman is going 2650, sorry, I said that wrong, 2600. After the collision, Superman must be going 26, say again. That's right, I had to think about it for a second, I had to do the math, it's not hard math. But if after the collision that the meteor, it is a meatball, but okay. The meteor is going 50 meters per second in that direction. In order to keep the relative velocity, then Superman must be going 2,600 meters per second in that direction. So again, if he started at 2,600 meters per second in that direction, that's a relative velocity of 2,650. Then that is a relative velocity of 2,650. I guess I could have made it more interesting by giving you a different velocity. Let's say that Superman stopped the meatball. Now that actually what happens if you conserve momentum and energy, because I wrote this out, is that the meteor is going away from the Earth at 54 meters per second. So that means that Superman is going away from is recoiling at 2,596 meters per second. That's the actual correct number if you conserve momentum and energy. Just notice that this velocity minus that velocity equals this velocity minus that velocity. That those relative velocities, not speeds, but velocities, are the same.